All right, welcome to Chapter 4, Section 7, called Linear and Nonlinear Functions. This is for Math 8, so a couple of things that you'll see on the screen here. The first thing you should see is a due date. I don't see a due date on my screen, but you will see one on the student side. Excuse me. The second thing you'll see are the attempts here. You always have unlimited attempts on the homework, the tests, and the quizzes, so you can come in and try them as many times as you would like. This particular assignment has 3 questions. Kind of just depends on the section for how many questions you'll have. Grading policy is best score, so whichever attempt is the best one is one you keep. Partial credit's enabled, so if you answer 1 of 3 questions correctly, you get credit for the 1 question, or however many questions you answer correctly. Down here, it just gives us this reminder. Once you start your homework, you must finish it before you can work on anything else. What that means is once I click start here on the student screen, so on your screen, down at the bottom right corner here, you will see the submit assignment button. I don't see it here on my teacher preview, but trust me, it'll be there on your screen. When you want to leave this screen at this point, whether you've started anything or you've answered 1 or all 3 questions, whenever it is you want to leave the screen, you click that submit assignment button. It does 2 main things. It stops the program from locking out all of your other assignments because it assumes that you want this attempt open, so you want to come right back to this one. The other thing it does is it actually makes an effect in the grade book, and your teacher can see what you've been doing. So 2 big reasons there. Just always click that button. Remember, you have unlimited attempts, so you can come back in and try again. And it also saves your place. If you've already answered something correct here, it's not going to make you re-answer it. All right, the other thing that you'll see on here are explanation, example, and message center. Explanation tells you that you're going to lose your question attempt because it's going to give you the answer or the solution to this question right here. Not just an example, this one exactly. So it's not going to give you the answer and then let you come and type in the answer. It'll have you come in on another attempt, but you can click example and it'll give you a problem type just like the one we're looking at. You can walk through and see exactly what it wants you to do here. And then once you're good, you understand, okay, I understand what it wants me to do. You can close this. You can open another one by clicking example again, or you can even message your teacher directly from the screen so that we know where to come help you because it attaches a picture. All right, so let's go ahead and get started with this one. So this is linear and nonlinear functions. So we are going to take a look at number 1, what is a function? So if we just look at the definition of a function, it is a function is linear if and only if a constant change in the input, which is x, yields a constant change in the output, which is y. So that's, one of those kind of mathy definitions. So if we, in other words, if we have a consecutive change in all of our x values, so x values are, when we're looking at the coordinates here, it's our first values. If it's a consistent change here in those, and also a consistent change in the y's, then it's linear. It means it has a slope. It has a constant rate of change. So what we want to do is we want to look at these numbers really quick. -4, 0, -1, 4, -1, 8, -1. All right. So for this guy, I did it kind of tall instead of going sideways like they did. So I actually made more of a table like function 3 and 4 because it's sometimes a little easier to look at. So if I'm looking at x, these are my x and these are my y's. So if I want to go from -4 to 0, I have to add 4. If I want to go from 0 to 4, I have to add 4. If I want to go from 4 to 8, I have to add 4. So I'm adding 4 for my run. For my rise, my y's, looks like I'm not changing at all. So this would be 0. Although this means that I have a change of 0 for rise, which is okay, because that means I have rise over run. So it's 0 over 4, which means I have a slope of 0, which just means I have a flat line. If I have a 0 on the bottom, that's when we have some issues there. We don't want a 0 on the bottom of our function, but a 0 on the top, perfectly fine. So this guy is linear. Let's see. Oh, I made the paper just big enough to fit there. All right, let's go to the next one here. Let's see, I think I can fit it over here. No. 5, 8, and 4, 11, and 5, 14, and 6. Okay. And we have x and we have y. All right, so now we're looking again. What's our change here? That'll be our run. So remember, x goes with run. X is left to right. So it looks like I need to add 3 each time. If I go 5 plus 3, I get 8, plus 3, I get 11, plus 3, I get 14. So our run is positive 3, and our rise, so it looks like I'm adding 1 each time. So I'm just looking at what is the change each time. I want to make sure it's consistent. If it's even different one time, then that means that this isn't okay. It's not linear. And they do every once in a while throw that in there where it'll be kind of same change. Oh, the last one's a little different. Something like that. So you want to make sure you look at each one. So this would have a consistent change of 1 over 3. So this guy is also linear. All right, let's look at these ones. Okay. So I have 3, negative 5, 4, negative 2, 5, 3, 6, 7. I'll go ahead and write this one out just so that I can save a little bit of time there. Just less switching of the colors there. Okay, so I have x, I have y. This is x, this is y. Okay, so let's focus on this one. This is function number 3. So let's see. Do we have a consistent change here? Looks like I'm adding 1, adding 1, adding 1. So my run, I'm going to add 1 each time. My rise, let's see, I'm going to add, to get from negative 5 to negative 2, I'd add 3. To get from negative 2 to positive 3, so remember there's negative 2 and then another 3, so this is actually, I'm adding 5. And then to get from 3 to 7, I'm adding 4. So this is not the same. Not same. Or the same, I should put. So that means this is not linear because it's not going to go down in a nice straight, or up or down in a nice straight line. It's going to be kind of this crooked little line going around. Now that's, a horrible little scribble, but it's not going to be a straight line is the point there. All right, let's look at the second one. So we're going add 1, add 1, add 1. All right, so the run is good. Now for the y, it looks like we are subtracting 5 because I went from 2 to negative 3. Now I'm subtracting 5 again. And it looks like I'm going to subtract 5 another time there. All right. So that gives me linear because it looks like we're consistent there. If I'm subtracting 5 each time, so I have negative 5 over 1, which would just turn into negative 5 if they actually asked me to type that in. Let's go ahead and check. Perfect. Continue. Let's see, I think we have another one that's exactly the same. So number 1 and number 2, they're asking you the exact same thing. So you're going to go through and check exactly the same thing that I just checked. You're going to say, is it consistent? And you don't necessarily have to. I'll show you on part of this because I know I wrote it out as a table each time, but I've also done it slightly different in class, just kind of going off of the paper they give you there. So you have the coordinates like this, negative 5, 7, because you don't necessarily have to rewrite all of these. I'm just doing that because I can't write on this board for whatever reason. My pen tool doesn't work on that one. So if I'm looking at this one, I can go, I know that all the first ones here are the x's. I just like the table idea because they're all nice and lined up. But I can go from here to here. I would have to add 3 to get from 1 to 4. To get from 4 to 7, I'd have to add 3 again. To get from 7 to 10, I'd have to add 3. So this is my run. And then I would have my y's. So I'll label the y's here. Those are the second ones in each one of the coordinates. So to go from 4 to negative 5, I would have to subtract, and I just realized this should be a negative 4. That makes a little more sense there. So I'd have to subtract 1 because I had negative 4. I went to negative 5, which means I'm going down by another negative. And then I went from negative 5 to negative 6. -6 to -4, now I've added 2. So I've gone in different directions. So this one is not the same, which means that this would be not linear. So that's, you just want to make sure. And so you can do it this way too, just using this same sheet. And I think I have students do that in class where we're just drawing these arrows from X to X and then from Y to Y. So the same idea as going down the side, they're just not nicely lined up for us. So I'm going to go ahead and go to number 3 here, just so that we can save a little bit of time on this video. I think, it's the exact same. Okay, so it's 3 of the very, very similar equations here, or similar types. So again, you're just checking, are they the same ratio for X and for Y? It doesn't have to be the same number. That's not what I'm saying. Run can be a different number than rise, but each one of the runs need to be the same and each of the rises need to be the same. If even one of the runs are different or one of the rises are different, you don't have a consistent change anymore. So you pick non-linear. But if they're all the same, so you have all the same run and then all the same rise, yay, it's a consistent change. So that was section 7. I will see you in section 8.